Okay, we're going to do question 2D, and the problem with this was it gives you no equations and it gives you no graphs. So there's a lot of information that has to be deemed from the question, and that is that the rocket's distance function from the fixed position has a maximum turning point at x is 5 meters and a minimum turning point at x is 8 meters. Now, that information basically tells us that we have a function, a distance function, that is a positive cubic, because we've got the maximum point being the first point at x is 5 and the minimum point being the second point at x is 8. Now, you need to have that information, and you need to make sure that you understand intuitively what that is talking about so that you can work for the next little while. So then we know that the differentiated expression is going to be a positive parabola. And we know its turning points basically are going to reflect better, but are going to reflect those turning points, right? So we let me just draw this a little bit better, shall I? So we've got these turning points, these max and min points are basically going to be our points that our parabola are going to hit in the x-axis, right? So our parabola, our differentiated expression, is going to be basically, it has a k in front of it because we have to assume that it's a k, minus 8 and x minus 5. And that's basically what our differentiated expression is going to have to be. And you have to be able to work at that point, from that point. And we also know some other information. The distance function passes through the point 10 and 15, where it has a gradient of -5. And we've got to find the equation of the distance function. So we've got to anti-differentiate. We've got to work backwards eventually, but we've also got to be able to get this full differentiated expression. We have to be able to get k. So we've got some information. When x is 5, we know that x is 5, and when x is 8, we know that the differentiated expression is going to be 0, because we know that about this whole thing is going to be equal to 0 at that point. So that's some other information that we can use, and we have a point. We have a point that we can use of 10 and 15. That has a gradient of -5. So we know that at x is 10, the gradient function is equal to -5. Now, there's those people that worked on this problem on the board should be able to do this question, because basically we've got a point of x is 10 and -5 for the gradient function. That's the gradient function. So we're going to plug that in. We're going to go -5 is equal to k, and then we have 10 minus 8 times 10 minus 5. And then we solve that. -5 is equal to k times 2 times 5. So -5 is equal to 10k. K is going to be -5 over 10, or -0.5. So that's my equation, then, is my differentiated equation for the distance is -0.5 times x minus 8 times x minus 5. Now, we're going to be working in the other direction. We're going to be anti-differentiating that expression because we want the original function. So once we got that, then we've got to work backwards, and we're going to have a c that we're going to have to deal with, but let's just work backwards. We're going to get -0.5 x. Let's just simplify this thing, shall we? Let's just simplify this. X squared plus 6.5x minus 20. If I multiply this all out and simplify, this is what I'm going to get. So that's another step that you have to do, obviously. Now I'm going to antidifferentiate. I'm going to get negative 0.5x3 over 3 plus 6.5x squared over 2 minus 20x plus c. It's not an easy antidifferentiation. We've got a lot of things going on, but you're going to have to be able to deal with that at an excellence level. Now, we've got a point, 10 and 15, on that original graph. So we're going to use that to figure out what this is going to be when we 0.5, 10 cubed over 3 plus 6.5, 10 squared over 2 minus 20 times 10 plus c. And then we've got to work out c, right? We're going to get c, when you do all the math around that, to be 56.67. Now, all you have to do is basically write your differentiated expression with your plus c in there. Now, if you use 0.5 over, negative 0.5 over 3x cubed, I mean, that's okay. But, I mean, you kind of would want to change that to something a little bit more meaningful. But you don't have to do this to get the question right. 4x squared minus 20x plus, and you can go 56.67. The answer key does 170 over 3. But basically, you're just going to take this expression and you're going to throw in plus 56.67 to get the right answer. That's